In last couple of episodes, we built the AI agent from scratch. We wrote a lot of code like the OpenAI LLM client and prompts and messaging queue and all the things. But now we have reached a certain state where we understood the how to create agent, but we need to leverage existing or more like a the new frameworks that can help us. And even I will explain why this help us. But today we are going to build our sort of a similar agent, but using a framework called LangChain. And this is sort of the framework that gives us a in starting a boilerplate code where you just need to start it at, but you need to get an idea. That's why we are moving to framework now after explaining everything from the start, like even the prompting and the React chaining and messaging queue. So that's how you can understand how the agent is behave. And now when you integrate into the framework, you can understand if it's failing, what can be the point you can understand. So you can figure out and debug it. Hey everyone, welcome back to this series of building AI agents. My name is Nitin Kumar. And in previous episode, as we explored, we in the last episode we explored the React agent, and now we are going to build the similar React agents using the LangChain framework. So let's understand what does it mean to leverage that LangChain framework, and what is actually the LangChain framework. So let's see. Google and search LangChain. So you will reach to this page, this official LangChain page, and there are a lot of things. But as of now, in the first start, we will go to the LangChain. So there are multiple things: LangSmith, LangGraph. We will come to that points, but we need to understand first the LangChain. So if you scroll down a little bit, there are a lot of things, but there's a thing. So it's the LangChain quick start agent with any model provider. And if you click on it, it will say build agent faster your way. So LangChain doesn't change a lot of things. It's giving you the liberty of building your agent just the faster way. It's not anything else. So and you can understand how you the proven agents or the typical agent framework agent sort of a pattern that we have already explored a couple of them. But now we will understand in more deeper like what is this LangChain and why this framework exists. So uh, let's see. So if you are recall the previous episode, you are aware in our code we were creating the OpenAI client by calling OpenAI, and then we were creating the response API by using client or GPT account chat completion or maybe response API. That's based upon your code. So now if we need to move towards the LangChain, so LangChain use sort of a similar ideas in the backend because we are going to use the tools, agents, LLM, everything is the same, but how they call it's a, that's the framework. It's a defined structured ways to call the things. So we call the LLM as a like chat OpenAI, and we define it tools by this decorator tool, and we can define our search tool and define even multiple also in the code. And why we are going to create the agent, we don't need to define a lot of things, and we don't need to even define the for loops or while loops that we have created in either 3 to 4 agents episodes back. We just need to call this create agent function from this LangChain, and then it will create all the things. You just pass your LLM tools prompt, and that's it. And then you will execute your code. I will show you. Just hold it a bit. But I'm telling you, you write a lot of things here, even like define the tools, you define the schema for the tools, while loop, tool, how to dispatch the tools, JSON parsing. Here, all the things are wrapped up into a just one line of code, and that's it. That's the game changer stuff. And if you are following this latest LLM sort of trends or new technologies, LangChain is the most popular thing I have ever seen in the LLM space. Like everyone is very heavily dependent on this. Okay, so on a stake, LangChain just provide you a boilerplate. Simple. It's the same result, same things. That's it. Okay, so now before deep diving into the code part, let's understand the basic concepts of LangChain. And if I break down the LangChain overall framework into some bits of or some concepts, so I will break into the six pieces. So one is a very basic one in the chat model where you call the LLM. That's a it work as a unified LLM interface. So for you can just swap all the models all LLMs, but just using by one line of change code change. That's it. Second one is the prompt, how you are going to pass your prompt. So you previously defined a lot of variables, roles, history, and all these things by the messaging. And now you have this chat prompt template. So it's already predefined templates that you can use, and they are usable. So it sort of save a lot of time and energy of your development cycle. Again, this next part is LCEL. I will explain all this concept, but it's a sort of a chains. So that's why it's LangChain. So chain is the main concept in this LangChain framework. So chain is something how you process in general way. You write your prompt, you call the LLM, and you use the parser for the auto parsing. Instead of defining all three function one after another, you create a simple chain. So you pass this thing all together into a system, and it execute prompt and then LLM and then parser, all three things all together in a chain. No, you don't need to break down the things and define separately. So that's a very beautiful concept. I would say it's a very interesting one. And next one is output parser. So even you just sort of looking some structured output from your system. Here you use the output structure. You can just use this library and the Python function, and then this tool decorator. This is auto schema. That's a very good advantage. You don't need to write a lot of schemas for your tools. And then agents, very interesting concept, because you whenever the whatever patterns you are building, reflection, React, anything, you write your code based upon that. But now by this LangChain, we have already the predefined sort of a tools agent tools. So you just call the create agent, and then you define the pattern, and then it creates the agent. Very easy. All these things, if you understood three six or six concept, I think you are good with the LangChain. I would say you don't need to learn a lot of the documentation, a lot of the concept around it, and even no need to watch a lot of YouTube videos. These three six concept basic concepts, you already know what how you are doing this thing. It's just the way you are going to do now. Okay, and now let's move towards the more concepts. So let's instead of just too much gyan in the theory, let's deep dive into I would say the code part. So let's understand how my code works. So very simple thing. First, how you are going to install the your LangChain. So I would say it's a not a rocket science. To be frank, you just need to do the pip install LangChain, and it will do. So pip install LangChain, it will do the all the work. Okay, so not a rocket science. I would say ignore it. But if you are doing first time, you need to do it. So, but yeah, that's done. Now, uh, I would say how you are going to import the packages. So let's just save the time. I will import by the code I have ready. So you just import by LangChain OpenAI, because I'm going to use the OpenAI calls and just for versioning check which version I'm using. And I already have my OpenAI key and all the keys into my .env file. I'm loading it, and my all the Travely OpenAI key, both keys are ready in my system. So if you are aware how we are calling R into the existing system, just a quick recap, I would say I will not write the code, let's say just understand the markdown flavor. So this is, we were using our previously LLM calls like from OpenAI, using OpenAI and client, we create the client and then response API, and then we call this response, extract our content, message content, and that's how you are doing. And this is a simple 8 to 10 lines, just calling the one LLM call. Now imagine doing some prompt tool calling, execution loop, prompt template, and we need to pass a lot of variables, even role and everything, and then output parser, memory, multi-turn model. This will you can imagine the length of the code will go huge, huge lengthy. So now how LangChain is going to save my life? What is the advantage I'm getting out of it, and how it will help me? So let's start with the very first thing is the chat model. So chat models, how we are going to use. So very first concept we will break down here. So chat model. So chat model, how we are going to import. So uh, from LangChain under OpenAI, we will first import our chat model. So chat OpenAI. This is the first thing we will import. Now we need to create our LLM, which are going to call. So we already imported the chat OpenAI, and we need to pass our model. So model, which is I am going to use the GPT, let's say 5.2, latest one, and I need to pass the temperature. So temperature I say is 0. So this is I am just defining my LLM function. Now how I am going to get my response. So response is now here's the slight difference. So instead of just invoking by this function by client dot chat dot completion, all this thing, we in LangGraph or LangChain, we we invoke by the LLM dot invoke. That's a small change. And now let's ask a very basic question. So let me can say just a couple of seconds, I would say. So this is a very basic question I will ask. What is an AI agent in one sentence? And let's see what answer I'm getting. So I'm just printing the stuff. So this gave me an AI agent that provided action and all. And here I'm exploring. This is first thing the message content I'm getting, and I'm getting a lot of sort of uses metadata that is very important to the tracing and everything that we create the dashboard and all. What is the input token I'm consuming and everything. So this is I am getting a detail by this simple 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 object. Now, even if I say how you were calling by the old API, so I would say this was the way we already know client chat completion and all this thing. You just pass use role user content. What is the one and it will give me the same answer. So I would say like you can change the LLM. This is different. Just ignore it. Like let's say 5.2. Even answer will be the same. So most probably. So now, first thing is clear how I'm going to call my LLM. It's a pretty straightforward. So just think simple two lines LLM how you define and you just invoke it. Now let's understand the second concept. I got to know okay how my chat is working. So now explore the prompt templates. So prompt templates is very interesting concept again. It give me a lot of sort of a time saving and all. So instead of building a lot of things by manually, I'll define a template. So let's import from LangChain core dot prompts and then import prompt template. Import chat prompt. So I have this chat prompt template, chat message prompt template. So as of now, I will import the chat prompt template. And now how I'm going to define my prompt. So this is by let me just so that's how I define chat prompt template from messages because I'm going to pass everything as a message from user system. So and system URA that's the placeholder role. Answer in style whatever style you are going to pass, and then user and whatever question you are going to ask. There's a simple template. And what are the things I'm going to fill into it? So let's say I have few values. Let's say I'm saying okay, you are a senior data scientist and answer in a style of the AI technical concise language. So this is you invoke. So this is a very basic one. You pass the variable role, style, and then question. So that's how you pass your message. Your message is ready by invoking the prompt. So simple. Now, if I just print it because I'm not still not invoke my LLM. So I have this my message ready system, you are a senior data scientist, answer is cosine. That thing same we were expecting. Now let's invoke the LLM. So response equal to LLM dot invoke and ask the question. Let's say we have the question in my message. What is the difference between my rag and the fine tuning? Let's ask this, and we have this answer by in response, but let's just print the response dot content instead of printing everything. Yeah, I got my answer. So on retrieval, augmented generation, and fine tuning, there are two differences: rag and first the fine tuning, and when to when use when, and practical use rule of thumb. Very straightforward. You use the prompt template and you fill the variables and later the same thing, how you are going to invoke your LLM. Okay, so now we are done with the two parts. So and let's if I say do this in a old style, old school way. So how would you do it? Like simple, you define the role, you define the system, and then even creative when you hard code this thing into the your raw message and then call this thing. So I would say instead of this hard coding anyone doing this thing, move towards the more advanced or best ways. So okay, now let's move to the next concept. Is the third one that I mentioned is the chains. So yeah, this was the chains. Yeah, chains. So now understand what is the chain. So chains, I use the one word LLCEL. So what is LCEL? LCEL is simple lang chain, and C stand LangChain LC, and we have expression language. This is the full form, and it's very intuitive one. So I will not go into more detail. It's an expressive language and simple how we are going to create how you are going to pass the things into sort of expression. We learned a lot of in compiler and automata, the expressions and mathematical expression, everything. That's the LangChain expression language, LCS. And we are going to use in this work is our the pipe operator. So very important one is the pipe operator comes into the picture. Pipe. So this is very important. And the core pattern is very simple. As I mentioned, what we need first is the prompt and the pipe operator. We do the LLM and the pipe operator and the parser. Simple. You have the input ready into the prompt. You pass to the LLM, get the parser. Simple. This is the pattern. Now let's code it and let's understand into more detail. So how which I am going to import. So again, LangChain core. So LangChain core has the output parser. All the things I have ready. So output parser and import the structured one. Structured parser. Capital S. Structured output parser. So this is the parser I am going to import for my parsing. And now I am going to build my chain. Chain is simple. The prompt that I created on the top, I will use the same prompt. Again, the pipe, as I mentioned, my LLM, smaller LLM, I defined on top. Pipe again, and my structure output parser that I just imported. Structured output parser. Simple. And this parser is a function. Very easy. Now my chain is ready. Okay. So if I print my chain, everything is predefined here. Easy. Okay. I just wrote a very, I would say 6 or 7, not the 6 or 7, but even the 4 words. And I have a lot of things ready in my system. Now, how I'm going to get my results. So that is very important now. So results, let's again, LLM.invoke. Instead of LLM.invoke, now we will, because we already have our LLM into our pipe, into our chain. So we will not use the LLM.invoke. What we are going to use? We will use the chain.invoke because now we have everything into the chain. So chain.invoke. Chain.invoke. And what are the variables we are going to pass? So again, what are the messages or everything I am going to pass? So let's say the few things is the variables because in my prompt I don't have any variables. So I will for very simplicity I am going to pass my variable and the questions here. So let's just do it. Everything. So here I am same Python expert, beginner friendly, and what is the decorator in Python? And let's just run it and get my final output. So print, I would say, let's print result. So if I print result, oh, I got my answer. Uh, Simple. It did all the things end to end by my calling prompt, invoking LLM, and then even parsing, structure parsing. So here I have the everything is a parser. So this is a Python function it gave. A decorator is a Python function or class that taken with the function has written new function adds more extra behavior without it. And this is the same exact by calling this function. And why decorator useful? They are commonly used for logging, timing, access control, and caching. Uh, that's the more about a Python concept. I will not go into that concepts, but yeah, it give me the answer. The core idea behind you getting this thing is to how you are going to use the chains. And this was my the third concept, the chains that we have discussed into our the 6 pieces. Now even we even explored this output parsers we by simple using. But now let's get more detail of output parser if you are even curious more about this thing. Let's break down even the output parser. So output parser. Okay. So how I'm going to already use the structured one. So let's use the different one. Import from LangChain, LangChain core, uh, from LangChain core, output parsers. And what we are going to use, let's use the import different part, the JSON. What are the parser? So we have these things, and we will use our JSON structured parser. Let's see, because very yes, JSON output parser. So JSON output parser is different parser. More specifically, the use case you are getting returned as a JSON output, where something you are extracting some key value pair from your data. Let's use the same example we use into our I think back episode, like getting the structured from a senior scientist from Google and get the role and everything. Now import JSON because we are going to use the JSON structure. So again, import JSON easy. And now I'm going to use the same JSON prompt. So what is the prompt? Is the chat prompt template from message and the system and my user. This is the same message. I'm not going to use any variable and everything. And now I need my chain. So let's say chain dot JSON chain. What is the chain? How does it use? So first is the JSON prompt. The prompt I have separate by pipe, LLM separate by pipe, and my JSON output parser, that is a function. Simple. JSON chain is ready. Now I'm going to invoke with the my question. So let's use my existing boilerplate code, right? Yeah. So JSON chain dot invoke and text is the Sarachan is senior engineer at Google working. Now I want sort of a into this structured way, exact name, company, role in a parsing way. That I am looking out of it. So now dump this into my JSON and let's dump it. I dump this output as into JSON, this result. And now I have this parse JSON. Name is Sarajan, company Google, role is senior engineer. And it's a parsed answer. Very easy. Now you must be wondering, okay, this is straightforward even the old cases. How we were doing it? So we were simply hitting it. We were not a concrete way. So how we are doing it? We have this response from this even passing as a response for JSON output, and then you're trying to load this as a JSON. And based upon my experience, I can say these things will not work 100%. There can be a lot of failures, and even this concept, even asking the LLM, hey, give me the output in just strict JSON format and all. It will have even some percentage of issue, I will not say some 10%, 15%. But yeah, there are some issues. Okay, now move to the next concept. What is we have a tool. So for tools, we have this tool decorator, and let's understand what is the tool decorator. So let's understand the tools. So we already using the tools, and we know we've created the tools for the search and even for calculator. Let's understand these tools. So how we are doing it? For our example, we will use the Travely at as we are using it for our uh, the regular internet search. So let's import my the tooling thing from LangChain core. Again, the same thing. Dot tools. So these are the codes I import my the tool. Okay. And again, we are going to use the Travely. So from Travely, why is my oh, oh Travely? Sorry, my bad. Travely import. I need to create the client. So I will import my Travely client. Now I have the Tavily. First, let's create the Tavily client. So I have this key ready. So I will not use the one. So that's how we are passing the OpenAI client that we have into our .env file. And how we were creating are the tools. So we already know the structure and everything. So that's how we were doing. We were creating the client. So try and accept and all these things. So I will not jump into the more detail. And this is my registry, a sort of thing where we have this all the tool details as a list. Now, how is going to my LangChain is going to use this? So we needed doc string and everything. So LangChain auto-generated a schema from doc string and int type. So this is the thing. And as of now, if you say we have not used any sort of LangChain stuff, but let's to move towards my more into LangChain area. And just give me a minute. Let's understand this concept as tool. So how we were initially defining our tool into our this tool schema and defining the structure and doc string and everything. This was the way. If you remember, we already know we first define the function, what is the type, and then name and the description, human readable, and everything type object, what are the things is required and all. So now what different things or sort of edge I'm getting by using the LangChain decorator, this library. So for this thing, let's import from uh, LangChain core dot the tools, import the tool. And we are going to use the Tavily. So from Tavily, we need to create the client for Tavily. So Tavily client. Okay, we have Tavily client ready. And how import it now? How we create the Tavily client? The simple we already know into our last episodes. So the main difference is we are going to use this decorator tool, and this thing by defining this as a decorator, it do lot of things automatically. So if I just define my Tavily function, so this is the function we use. This is my doc string, and this is the again the simple code that I am going to do in my Python function. Nothing more than that. It's a simple Python function with a doc string. So it's a straightforward, I would say. We are not doing a lot of things here. So again, let's define other calculator function. So I'm defining the tool. My this function is a tool, and then how we are doing the calculator thing. So very basic calculator we were defining is a defined type calculator is a find the function. It's a doc string, and this is the try expression eval. That was the function simple for calculation. Nothing different as a usual Python function, exceptional this decorator, and this function automatically become my the tool. So first thing I need to create this list as a tool, the list of this tool to pass into my LangChain, and let's understand how this thing is changing all the work that you are doing as of now manually and by simply this adding this decorator. Now everything is ready. The tool schema is sort of auto-generated. You have this argument. Everything is now ready. The name, description, argument. What are the things you are defining by manually here? Description, argument type, and everything is now properly done by my this LangChain tools. Now comes to the more important, or I would say interesting part, or the last one I would say is the agents. How I'm going to create the agent by my LangChain. So we already know how we were creating the agent by defining my this while loop and all. So now I will not go into that code because this thing what is already available in the playlist. You can go and watch even the last episode. This React we already explored the React prompting. So now just understand what are the things we are going to use. So we already have the libraries and all. So I'm going to use a package that will very useful from LangChain is LangChain dot agents. Very useful. And here I am going to use this package name create agent. Very simple one. Everything I think we mostly have this tools, chat OpenAI, and even Tavily and everything. Let's define my model. What model I'm going to use? I think we already know this ChatGPT model. Let's just again define it. So we have this model. We will use this 4.0, no issues at all. No worries. And we already defined our tools, so we will not do the tools. Now let's create the agent. So I will create my agent. Agent is equal to create agent. That's the function we are going to use. And what are the things we need to pass? So for agent, my very first thing is the model. And model is my LLM that I already defined it. Okay. Second is I need to pass that list of tools. We already created the tools. So just passing the tools. Next part is pretty important is my system prompt. So system prompt, I need to create the system prompt for my agentic loop. So system prompt, I will instead of typing, I'll use it. So this is my system prompt. You are a React style search agent. Use the tool for factual questions. Search step by step for multi-op questions. Search when entry first, observe the result, then entry. Simple. The same as we are defining our the React one. This is simple way of creating agent. Now you must be wondering, okay, I have created, how I'm going to get the response? The same thing by using the invoke. So result is equal to agent. I have this defined and that invoke. And as the same thing, I need to pass the variables that in my message role, everything. So how I'm going to define? So let's define my first thing is the message. So messages will be my user and everything. So for clarity. So now create a dictionary for messages because I'm going to first define my role. So role is, let's say, my user because I'm asking the question. System is already aware. And what is the content or sort of a question that we ask? Content. So we will use the same example that was mentioned in the React paper. Aside from Apple Remote, what are the devices control the program? For this question, we need the internet access, and that's how we use the Tably. And by invoking this thing, it will run the agent in backend, and let's see the output by printing. Get my message and then result message. Last one, I pick it and then get the response. So now by this thing, I got my answer aside from Apple Remote. The one for the all URC remote can control device percentage and print remote and everything. So now ask the defined question. So let's invoke it for the defined question we were using Apple Q3 revenue and what is the 50% of it. And let's understand this question. So definitely it gave me 12.85. That was the same answer I am getting. Now let's break down the answer or the response we are getting from the result. So you need to just result or message. And if we iterate of it, we will first print what is the message type and what is the message. So message type is human. That's I asked the question. There is no additional argument and no metadata. This is the answer I am getting from my AI. This is AI message, token uses, and everything. And this is the tool that it used. And this is the AI message. And again, the tool because the calculator it used. And this is the tool it used for the internet search. And okay, here is mentioned web search. Here must be mentioning about the calculator. So yeah, it's pretty straightforward when you use the this thing into the tracing in LangFuse and everything. These things are pretty important. You are going to log all the keywords, all the tokens and everything. That's why it's very important to do the things. So now if I say how can I do without the LangChain? So I will not go through line by line of code, but I will give you a very quick glimpse of how we are going to do it. So first, that's how we are defining our raw agent. Uh, so importing libraries and yeah, importing libraries, then creating client OpenAI, and then you defining the tool schema for each tools. Then you map. We can simply do it, and there's the message, and then you just create a loop. So you are just defined for 10 passes, and even you can iterate even while loop till this get answer requesting some tool and all. Different patterns, but yeah, for agent for React, that's a different pattern, and then you write this long of code, and even you if you expand the new tool, you need to write a lot of things, and even the functions will be hard to call by these things. Yeah, so this is a sort of a LangChain that gives the edge on a lot of things. So why we are going to use very first thing is the LangChain, and this raw code is manual, lot of manual tool schemas, looping, parsing, everything. LangChain, we just use the create agent tools and invoke, and that's it. and we got the final answer. Nothing fancy, very straightforward. And then what is the sort of a edge I'm even getting on top of it? So it's a comparison is when the line of in the raw code line goes like simple, very basic agent 30 to 40 lines. In LangChain is a 10 lines. Tool schema is manually JSON, but we have a decorator. We by loops we create the while and all. We have this agent executor, and lot of the advantage. And with the memory management, we have created the manual list. Here we have the automatic list and all, and result reswiping and everything. It's slightly good if you are exploring the basic nitty-gritties and understanding the basic concept. But yeah, when you got an idea about the things, you always move faster. So that's how this framework help you to move faster into your development cycle. So yeah, and even if you know these things very basic, all the like basics and all, in even the production when things fails, you know which part is failing and where I need to fix. So that's why I am adding this LangChain slightly later into this series, because you need to understand first what are the things. So okay, we already explored this part, like what is the prompt model and parts are. We already wrote the code. I will not say we we understood why this prototyping is very faster, and even built-in lot of memory streaming is easy. And raw code helps to understand the basic things when need to debug in the production. Very important, all the things all together, I would say. No need to jump or skip this part. So that was the idea of this framework, and that's why I created in this sequence. So you will have a lot of ideas about the basic thing, and then now it's good, good flow. Okay, so sort of a final takeaway, I would say. So LangChain is not a magic, to be frank. So you don't behave like Zen is a magic. It do everything, but it's sort of a combine everything and gives you a sort of a built-in uh, packages function that you can actually leverage and do your stuff. So simple rule: first learn the prompting, agents, looping, and everything, and then move towards the LangChain, I would say. Okay, that's the best way to learn, and that's the best way if you are really interesting to build some production grade AI agent, I would say. Okay, so now we already understood the LangChain framework. Now, in the next episode, we will go into more deeper uh, towards new technology, how agents need state, branching, retries, and even some conditional routing. And simple, till now, we just, whenever we are creating agent, we say loop, while loop, or different loop. But simple looping is not a perfect idea. So these loops, these while loops and all this, like iterated loop, for loop for 10 times and all. This thing is good for very basic thing, but it's not ideal state. So what is the next thing? We are going to explore the second part of this LangChain is LangGraph. So there is a graph that define our path of our agent, and that's how our agent execute and give the best possible results. And that gives a lot of the edge from this static based architecture to the more dynamic and more advanced, I would say, and gives more confidence into your agent. So in the next episode, we will learn the LangGraph, not the LangChain. And if you like this episode, like, hit the like button, subscribe to the channel. I know there was slightly gap into the last in this last episode, in this episode, but yeah, I'll try my best to keep uploading the videos as frequent as I was doing initially. But yeah, thanks for watching and keep learning. Bye bye.